Okay, so in this video here, we're going to be talking about one of the most important things that you can do when factoring quadratics, and that is pulling out a greatest common factor. So if you're on this video, we're assuming that you know how to factor a quadratic, and typically the way I teach is the AC method. So we can factor a quadratic when a is equal to 1 or a is not equal to 1. So if you go ahead and look at the first example that I have here, you can see that a is not equal to 1. So if you're going to use the AC method, you would do a times c, meaning you would do 3 times a negative 12, and that would give you negative 36, right? And then you would say to yourself, okay, I need two numbers when I multiply that will give me negative 36, but add up to my b, which is technically 0, right? I don't have a b here, right? I don't have that bx term. Technically, my b is equal to 0. So those two numbers would be negative 6 and then positive 6. And then you'd have to go ahead and factor by grouping because a is not equal to 1. So this is why you always want to go ahead and try to pull out a greatest common factor. It's going to make the problem way easier, and then you may not have to do factor by grouping, and the problem's going to be much, much shorter. Now, I just want to reiterate here, if you were to factor by grouping here, meaning you're going to grab these two numbers here, negative 6 and positive 6, you're going to go ahead and rewrite it as 3x squared, and then negative 6x plus 6x, and then minus 12, and then go ahead and group it. When you do that, you are going to get the same answer, but again, it is going to be more work, and you want to avoid the amount of work that you have to do. And actually, why don't we go ahead and factor by grouping here? That way we can compare the two different answers by doing the easy method after. So if you look at your first grouping here, we can pull out a 3x, and then that will leave us with x, and then minus 2. And then looking at our next grouping, I can pull out a positive 6, so plus 6, and then I'll have x minus 2. My confirmation is the common factor, which is x minus 2, meaning I did it correct. So I write my common factor one time. Then I write my outside values together right here, 3x and positive 6. Okay. And then technically on this factor here, you can still pull out a 3. So rewriting the whole thing, you would have 3, and then you'd have x plus 2, and then x minus 2. That would be the complete factorization, right? And that is factoring by grouping. But again, the easy way to do it, always pull out a greatest common factor. So if you go back to the original example, if you pull out a 3, what happens? Well, I'm going to pull out a 3, and then I'm left with x squared minus 4, right? And then from here, you can go ahead and do the AC method, or you can recognize that what you're dealing with right here is a difference of two squares, right? So all I need to do here is do 3, and then I have x plus 2 and x minus 2, and you're done. There it is, completely factored. So if you did not recognize the difference of two squares, that's fine. Go ahead and use the AC method on x squared minus 4, and you're going to get this factor here and this factor here by doing so, okay? So it won't matter how you do it. But again, recognizing that that is a difference of two squares is definitely going to be a lot quicker. So you can see that they compare exactly the same way, right? So always pull out a greatest common factor. Let's go ahead and take a look at our next example. So here's our next example. And again, if you were to just go for it and do the AC method, you would have to do factoring by grouping here, and it's going to be a lot longer. So before I do anything, I'm going to see if I can pull out a greatest common factor. And on this problem here, I can pull out a 4. So if you pull out a 4, that leaves you with x squared minus 4x and then plus 3. And now what we're going to do, we're going to factor this quadratic here, and this 4 that we pulled out right here will come along for the ride, okay? So if I do a times c, what do I get? A times c, that is going to be 1 times 3, I get 3. I need two numbers when I multiply, that will give me 3, but add up to negative 4. That's going to be negative 3 and negative 1, right? When I multiply them, positive 3. When I add them, negative 4. And from here, you just go ahead and factor this quadratic, and you're done. And again, remember, the 4 does come along for the ride. So we write 4, and then we write x minus 3, x minus 1, and then we're done. All right, there's the complete factorization. Okay, let's go ahead and try some more examples. So here's our next example. Can we pull out a greatest common factor? And this one we can. We can pull out a 5. And we can also pull out an x. So pulling out a 5x, then we have x minus 1. And from here, you're done. Right? There's nothing else I can do here. I'm completely done. Here is the complete factorization, right? So again, you always want to pull out a greatest common factor because sometimes when you do so, you don't even have to factor anything after you do that, right? The problem will be done. And in this case here, we are done, right? Nothing else we can do here. All right, let's go ahead and try 2 more examples. So here's my next example. And this one, you can definitely do the AC method. But first, can you pull out a greatest common factor? And the answer is you cannot pull out a greatest common factor here. But this is very unique because it's actually a difference of 2 squares. Now, let's say you didn't recognize that and you do the AC method. That's fine. If you do A times C, that will give you 1 times a negative 64, and that will be negative 64. So 2 numbers when you multiply, that will give you negative 64, but add up to your B. Now remember, you don't have a B. And when I'm talking about B, I'm talking about a quadratic in standard form. So again, when you have ax squared plus bx plus c, we're talking about this value right here, this b, right? I don't have one here, meaning it's 0. B is 0 here. So 2 numbers when I multiply, that will give me negative 64, but add up to 0, well, that's going to be negative 8 and positive 8. And a is equal to 1 here. I can go ahead and put it right in factored form. You get x minus 8, and then x plus 8, and then you're done. There's the complete factorization. Now, that's the AC method, but this is actually a difference of 2 squares, and a way to recognize that, first, using algebra, you would write it as a squared minus b squared, and this would expand out to a plus b, and then you would have a minus b, okay? So if you can recognize that, you can go ahead and expand it out. So for example, if you look at what you have here, we can rewrite that as x squared and then minus 8 squared, right? That would be the same thing. And then expanding it out, you can see how you're going to end up with a plus b and a minus b. But an easier way to recognize it, in my opinion, if you notice that you do not have that bx term, like we don't have that bx term here, okay? There's always a possibility for a difference of 2 squares if that occurs and your constant is negative. So again, if you do not have that bx term like we don't have here and your constant is negative, you have the possibility for a difference of 2 squares, and all you have to do is test. So for example, if you take the square root of your constant and it's a perfect square, that means that yes, you do have a difference of 2 squares, and we know that the square root of 64 will be plus or minus 8. Hence where our factors are coming from here, right? So again, if you do not have that bx term and your constant is negative, all you have to do is check by taking the square root of your constant, and then you can determine if you're dealing with a difference of 2 squares, okay? So this one's done. You get x minus 8 and x plus 8. Let's go ahead and try one more example. So here's our last example, and on this one here, it's a bit different, right? Can you pull out a greatest common factor? And the answer is you cannot. But what I want you to recognize here is a pattern, and that is the pattern of doubling. So for example, if you look at this term here and then this term here, look at the exponent value on those variables. I'm going from 3 to 6. I'm doubling, right? Well, if you go back to a quadratic in standard form, ax squared plus bx plus c, we know that I have that same pattern, where on this term here, my exponent is 1. And you can see that as I go from 1 on this term here, bx, and then going to this term here, my exponent is 2, I'm doubling, right? So if you have that same pattern, you can essentially factor it the same way you would a quadratic. And the way we're going to do this is by using substitution by u. So substitution by u is how you can essentially factor a polynomial the same way you would a quadratic, even though it's not technically a quadratic. And the way to recognize that is by looking at your exponent values. They should be doubling, and on this example here, they are doubling, so I can use substitution by u. So for example, I'm going to say u is equal to, now when you do substitution by u, you're always going to be using this term right here, and in particular, you're going to be using not the coefficient, I don't care about the 5, but I'm going to be using the variable and the exponent. So for example, I'm going to be using x cubed here, okay? I'm going to call u x cubed, and then I'm going to rewrite the problem in terms of u. So think about it. If I have x to the 6th power, how can I go ahead and rewrite that in terms of u? Well, that's going to be u to the 2nd power. And then I'll have plus 5, and then x cubed will be u, and then plus 6. And then we're going to factor it just like we would a quadratic. So doing a times c here, that's 1 times 6, I get 6. So 2 numbers when I multiply, that will give me 6, but add up to 5, that will be 3 and 2. And so since a is equal to 1 here, I can go ahead and put it right in factored form. I get u plus 3, and then u plus 2. Now you're not done yet. You have to go ahead and replace u with what it actually is. U is x cubed, so finally we can write x cubed plus 3, and then x cubed plus 2. And here we go. Here's the complete factorization, okay? So that is it. Again, the takeaway of this video here, the most important thing you can do when factoring quadratics is always check to see if you can pull out a greatest common factor. Because by pulling out a greatest common factor, you're going to avoid the possibility of having to factor by grouping. Now, sometimes you will have to factor by grouping. There's no way around it. But if you can pull out a greatest common factor and make that a coefficient 1, you definitely want to do that because, again, then the problem becomes way easier and it becomes way more manageable, okay? And again, on this last problem here, this was more of a bonus. This is called substitution by u. Again, we couldn't pull out a greatest common factor, but we had that pattern of doubling. So if you see that pattern where you're doubling on your exponent values, you can go ahead and use this method here. So that is it. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.